YouTube, welcome back to the Allegheny Northern in N scale. Today we're going to do a DCC engine shop edition, and what we're talking about is speed matching. So here's how this became a thing. The three locomotives on the left were in charge of pulling this coal train. This coal train that you're seeing here is just the first 5-6 cars of a 36 car train. And as they were coming up the 2% grade, right around the powerhouse there, and getting into the S curve, there was too much weight on the end of the train, and although the locomotives could pull it, the cars couldn't stay on the tracks. So I figured, well, I need some distributed power. Rather than break up these three locomotives that are consisted, I was going to add this Athearn NS unit somewhere in the middle of the train to take off some of the lateral forces. Unfortunately, it was not matched in speed to the three locomotives on the left, so I didn't even bother putting it in the consist, knowing that my train would either be pulled apart or squished, with the locomotive in the middle pushing or pulling, depending on what it was doing. So I decided we got to speed match the NS unit to the NS heritage units. So what do I mean by it not being speed matched? Well, as you can see, the three units on the left are crawling, and our unit on the right is slowly overtaking them. Okay, so what we need to do is modify several CV values on the decoder to make the performance of the faster locomotive match the slower performance of the three on the left. So the variables we're going to be dealing with today are CVs 2, 6, and 5. And no, I didn't say them out of order. 6 happens to be the mid value, and 5 is the high value. So let me get into that right now. I'll show you what I'm talking about. First, let me show you the equipment that we're using here. So I have the Zephyr Express. It's the DCS 52. I do have a DT 500 throttle that I use. It's radio controlled thanks to this little guy right here. And when I bought my main system, my command station and booster, you get this little book, and it tells you about the different control variables to some degree. Now, for those of you who have been in DCC for a long time, you know that your locomotive and your decoder has multiple control variables, and they can control all sorts of different things from sounds to lights and various operating functions. But the ones we're going to be focused on today are the speed controls. So 2, which is your start, your 5, which is your max, and your 6, which is the midpoint. Okay, I have no idea why they picked the numbers, not even going to pretend to guess why they're out of order. Doesn't matter, but that's how it plays out. There's also an example here of a possible speed table, and it gives some values as to what these different types of locomotives may be. Now, if you got yourself a starter kit like I did, you probably got this manual here just so as part of the kit, so that you know what exactly you're doing when you're starting out. Okay, so basically, to summarize what's going on here is you've got numbers from 0 to 255. 0 being your starting point, 255 being your max voltage. Every number between here and 255 represents an increase in power. And when I say increase in power, if you're reading right here, each value increment represents an increase of approximately 0.5% of the total modal drive voltage. Okay, so if this is your starting point and this is your max point, imagine it on a straight line bar chart. So the more power, more speed, that sort of thing. So we've got our locomotive sitting on its programming track with the Zephyr Express. I want to go into the quick read real fast here so I can show you what the decoder is showing just right out of the gate. Now, this does have a Digitrax decoder in it, which makes reading very, very simple. And you'll notice that there's my stats. So right now, its normal direction of travel is off. I'm using a 28 step, not 14. The analog's on, though it doesn't matter. Speed table is off, and I'm using a long address. Now, I'm using simple consisting here in that the 3 locomotives on the track, along with the one we are programming now, all have the same address as the lead locomotive, 7533. Technically, I should be consisting them in an advanced consist because the helper unit at some point may break off. But for our purposes, we are just running trains around the track. I don't need that sort of control. So, I've gone in here now, and I want to go to the individual CV programmer. And I am on a programming track, so I'll also select 2. And now you see that it's asking me to input a CV number and a CV data. I like to start with 2 just because it's the first one, and I want to give it a value of 0. I'm going to go ahead and write that value. Now I'm going to go back and I'm going to do CV value of 5, and I'm going to give it a max value of 255, knowing that that's what we can achieve. Okay, now I'm going to go to 6, and I'm going to give it a value of 127, approximately half of what the full value is. So I call this my 0 point. Everything is linear at this point. There's no modification. So let's put it on the train. Let's put this train on the track here, and let's see what this locomotive does with the other 3. Okay, so let's see what our damage was here on the locomotive and see what our speed performance is. As we throttle up, you notice that our NS locomotive is not taking off nearly as fast, although it is still a little bit faster as we approach speed step 10 here. Beforehand, this locomotive was tearing off, and now it's sort of almost in line a little bit. So, maybe a little bit more adjustment, and we'll be pretty close. Okay, back on the programming track here, and obviously we know that our start value is already 0. So changing our start value is not going to help us out any because it's already as low as it can possibly go. So let's take a look at our CV data for 6. That's the midpoint. So what's happening is our locomotive is accelerating too fast from, look at it as from our 0 point to our midpoint. It's trying to get there much, much faster than we want it to go because it's outpacing the other 3. So what we're going to do is take this CV value and we're going to bring it down. Now, there's no way to tell how much or what the correct value is, so I like to pick something extreme so that I can totally see the difference in what I'm doing. So right now my value is 127. I'm going to drop this down as far as 80. Okay, let's go ahead and write 80 in there. Now mind you, there's not much space now between 0 and 80 as there was between 0 and 127. So what this locomotive is going to do is it's going to slowly crawl, or slower crawl, from 0 to the midpoint of 80. Then once it hits the midpoint of 80, it's going to accelerate quicker, getting from 80 all the way up to 255. So let's take this over to the track and see what our performance is. Okay, so I didn't bore you with all of the numbers that I played with. I've actually only tried a couple. Right now I've got it at a 0 start, and then I have it at, so CV2 is 0, and on my CV6 value is 75. Now that's a pretty big decrease because if you recall, CV6 started out at 127. So when we get this train started, what you'll see here is that's speed step 10, and although our Norfolk Southern is still a little bit faster, for the most part they're staying together, much more so than they were. So this is pretty close. I don't think we're going to get a whole lot closer. There are some other control variables that you can play with. They are they are 3 and 4. So that is the rate at which your locomotive will accelerate and decelerate. Those 2 variables I haven't messed with a whole lot, but what it does is it basically will delay the response in the throttle. So if you throttle up, it takes a few extra split seconds before your locomotive responds. So what I want to do now is, I think I've got this thing fairly close to what it should be, and the true test is to put it in the train as a mid-unit helper and see how my train fares on the hill. So let's see what we did. Okay, so we can see now that our speed matched locomotives are doing pretty well in a lead locomotive and helper consist. But let's talk about helper operations here just for a second. So if all 4 of these locomotives were on the front, then there wouldn't be very much issue with operating. When I have a helper unit on, whether it's mid-train distributed power or actual helper at the end, I always get a little nervous because it's not the easiest thing to do, and any kind of speed bump in one locomotive set or the other, and you got cars absolutely all over the tracks. So to me, and for my purpose, helpers are kind of a gimmick when I want to put a really long train on that I don't necessarily need, just because, well, let's face it, really long trains, especially coal trains in coal country, are pretty cool. So, but if you're going to do helper service or distributed power, some things you need to consider. One, your locomotives need to be very closely speed matched, and your tracks need to be clean and reliable. Because if at any point in time one set of locomotive stalls or bumps, like I said, you get cars all over the place. The other thing that you got to consider is the weight of your cars. It's good to make sure your cars are all properly weighted, and MRA sets standards for that. Also, it's good that your couplers are body mount, not truck mount. Now, all of these are truck mounts, and they're doing okay, but the body mount gives a more rigid frame through the entire train for the train to push and pull, and little jerking motions don't affect the car as much as they do the individual truck. So if the train jerks in any way, that force is directly applied to the trucks, which can turn the wheel set, you know, off of the rails. So body mounted couplers properly weighted and clean tracks, I guess, are the rules for the day. If you have these items, you should have no problem using distributed power units. The other thing that you're going to want to do also is just give it a try before you show off in front of guests. Just because if you do end up with an issue somewhere and you've got cars all over the place, it's not quite as impressive. So anyway, that's it. That's how you can speed match your locomotives, and kind of a complicated setup here, but make sure your couplers are the right heights. Make sure that they are on properly weighted cars, and of course, speed match your locomotives.